Very good evening. So in this video we are going to learn about analysis of variance. In statistics, analysis of variance will play a dominant role while analyzing the data. And the objective of ANOVA is to test the differences between three or more groups which are there in a particular data set. So we can able to test whether the means of all three or more samples are equal or significantly different. In our daily life, or especially in business situations, we will have more number of samples. Therefore, ANOVA will play a major role while analyzing the data to test a hypothesis with three or more samples. So generally, this ANOVA is of two types: one-way ANOVA and two-way ANOVA. Then what is meant by one-way ANOVA? So whenever the data set is influencing by a single factor, then the analysis is called one-way ANOVA. For example, if we have three fertilizers, let's say A, B, C, and if you have the data on fertilizer A and fertilizer B and fertilizer C, and if you assume that the data is influencing with only factor called fertilizers, then we say that the problem is coming under one-way ANOVA. Sometimes the data might be like this. So let's assume A, B, C are fertilizers and various types of temperatures, let's say warm temperature and various temperatures are influencing in the rows. So columns are representing for fertilizers and the rows are representing for typical temperature. Then whatever data we have will be influenced by fertilizers as well as temperatures. Therefore, this situation is coming under two-way ANOVA. So, ANOVA can be used to analyze the data when we have a single factor or two factors. So now let's go with an example based on ANOVA. A random sample is selected from each of three makes of ropes, and their breaking strengths in pounds are measured, and that measurement was given with the following results. So here rope 1, rope 2, rope 3 were taken, and their breaking strengths were given. Under sample 1 we were given with under rope 1 we were given with 5 samples, under 2 we were given with 7 samples, under 3 we were given with 6 samples. Okay, now the question is, test whether the breaking strength of the ropes is significantly different or not. So let's go with the solution. As we know that ANOVA can be applied for testing of hypothesis. So testing of hypothesis basically follows with 5 steps. So step 1 is null hypothesis. As we know that null hypothesis within the brackets H naught. So obviously in the null hypothesis we assume that there are no significant differences. There are no significant differences between the average breaking strengths of ropes. So that is H naught is hyphens to x1 bar is equal to x2 bar is equivalent to x3 bar. So we assume that the mean of first sample the variable as x1 for the first sample, variable for second sample is x2, and variable for third sample is x3. So after null hypothesis I have taken alternate hypothesis. This is purely opposite to null hypothesis. So in the null hypothesis we have taken no significant differences. So in the alternate we have taken there are significant differences. So my alternate hypothesis will become x1 bar is not equal to x2 bar is not equal to x3 bar, and level of significance was not mentioned in the question, so I have assumed as 5%. Now the test statistic. So in the ANOVA, the test statistic is calculated with the table. The table I will draw, and it is shown like this. So this is the table which is coming under step 4. So in the first column we have source of variation, next is sum of the squares, degrees of freedom, mean square, test statistic. Coming to the rows, we have calculations between the sample. Between the sample means the calculations between first sample to second, second to third, and third to 1, like this. So between the samples, and the residual error. So error we need to calculate. Now coming to the first box, if you observe this box is relating to sum of the squares and between the sample. So we can say that this box is coming under SSB. SSB means sum of the squares between the sample, and this will be sum of the squares of residual error, so it is SSR. And coming to this sum of the squares of total, so it is SST. It is SST. Okay. Now coming to degrees of freedom. So in the degrees of freedom between the sample now, so we need to write. So how many samples are there? 3 samples. So between the samples, so it will become. So degrees of freedom for between the sample is between the samples. So there are 3 samples now. So in this example, 1, 2, 3. So between the samples, so degrees of freedom is always total sample minus 1. So it will be 3 minus 1 is equal to 2. Whereas degrees of freedom for error, n minus k, where n means total number of subsamples. This means under first one we have 5, under second one we have 7, under third one we have 6. So 5 plus 7 plus this is 6. All this is all together is 18, minus k means subsample, I mean individual samples 1, 2, 3. So 18 minus 3 is equal to 15. Okay. Now coming to the mean squares. Mean is nothing but this total divided by degrees of freedom. So this total means SSP. So first of all, mean squares of between the sample can be calculated by, can be represented by MSB. MSB is equivalent to this total, and SSB divided by K minus 1. Similarly, average of residual error is MSR is equivalent to SSR divided by n minus k. Okay. So, and coming to the test statistic, I will tell you. So that is F we are going to learn. Now if you observe, to find out the calculated value for F, we have to take MSB by MSR. To find out these two, we require SSB, SSR. So our target is need to calculate SSB and SSR. But before going to calculate SSB and SSR, we have to calculate an error, that what we call correction factor. So that correction factor is calculated by CF is equivalent to grand total whole square divided by capital N. Capital N means total subsamples. So grand total means, so grand total is nothing but total of sample 1 plus total of sample 2 and total of sample 3. So we can say that grand total is nothing but summation of x1 plus summation of x2 plus summation of x3 whole square whole divided by n. So this implies total will be 380 plus 770 plus 380 plus 770 plus 426 whole square by n means total subsamples. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So total subsamples are 18. So I have substituted summation x1, x2, x3 and whole square by 18. So sum of all this is equal to 1576 whole square by 18. If you take this into calculator, you will get this value. So this is about correction factor. Now we are going to calculate for SSB. So here SSB is calculated by, see we have 3 samples na, that is some, see this is our problem. So here SSB is calculated by, see what is the first sample? First sample we have assumed as x1. So summation of x1 whole square by how many subsamples are there in sample 1? 1, 2, 3, 4, 5. So this is representing by n1 plus second sample is summation of x2 square whole divided by n2 plus third sample is summation of x3 whole square by n3. Got it? But remember, while calculating SSB or SSR or SST, we have to take minus correction factor. So SSB is calculated by summation of first sample whole square by n1 plus summation of x2, that means second sample whole square by n2 plus summation of x3 whole square by n3. But remember, minus this correction factor we have to subtract. This implies SSB is equivalent to summation of x1 means, if you see here it is 380. So this will become 380 whole square by n1 means subsamples in first one, that means 3 plus 2 5. So this is 5 plus my second sample total is 770 whole square divided by my second n2 means 3 4 7. So this is by 7 plus third one is 426 whole square by third sample total number of subsamples in third sample, it is 3 plus 3 6 by 6 minus correction factor is, this is our correction factor, that is 137,987.55. This implies, now if you simplify this, 380 square by 5 means 380 into 380 by 5, you will get 28,880. Similarly 770 into 770 by 7, you will get 84,700. 426 into 426 by 6, you will get this minus correction factor. If you simplify all this, you will get 5838.45. So this 5838.45 we can write here 5838.55. 5838.45. So this is 45. Okay, I hope you understand till now. This is 45. Now once you get SSB, already we have k minus 1, so we can go for MSB. So MSB is nothing but 5838.45 by k minus 1 is nothing but 2. So this will give you 5838.45 divided by 2. It will give you 2919.22. Okay, 2919.22. Now coming to the next, our next requirement is MSR. To find out MSR, we need to find SSR by n minus k. But remember, SSR we cannot find directly. So what we can do, if you see the first column, this is SSB, this is SSR, this is SST. And SST means total na, and this means the sum of SSB and SSR is equal to SST. So when we are unable to calculate SSR directly, then what we can do? We can first find out SST SST, then SST minus SSB will give you SSR. So instead of calculating SSR directly, better to write this SST minus SSB will give you SSR. So now we are going to calculate SST, where SST is nothing but the total of squares of all the samples minus correction factor. This means whatever subsamples we have. So we have all the subsamples now. Now we have to take square of all the subsamples. That means 70 square, 72 square, 75 square, 80 square, 83 square, and so on. So we have to take squares of all these values minus we have to do correction factor. So now let's apply this SST. Now SST is nothing but this 70 square, 72 square, 70 square plus 72 square plus. So after squaring of all these values, so these are squares, and minus correction factor. So sum of all these values will give us 144,952 minus correction factor. This will give us the final value. This is SST. So once we get SST, then this SST value minus SSB obviously will give us SSR. Therefore SSR is equivalent to SST minus SSB. So this implies 6964.45 minus SSB is nothing but what? SSB is 5838.45. So this will give us, so this I am just putting in the calculator. That is 6964.45 minus 5838.45, which will give us 1126. So this SSR is equal to 1126. So this is 1126. So with this we can find out MSR. MSR is nothing but SSR by SSR means 1126 by n minus k means 15. So this is nothing but divided by 15 will give us 75. So this is 75. Okay. So now we have both MSB and MSR. Therefore, a test statistic F is equal to MSB divided by MSR. This implies 29. So this is 2919.22 divided by 75. So this will give us, I'm taking this in calculator, 2919.22 divided by 75 will give us 38. This is 38.92. So this is our calculated value. So therefore 38.92. Therefore, coming to the conclusion here, F cal is equivalent to 38.92. Okay. Now we have to take a tab value. So F tab is equivalent to, we have to take F tab value at the rate of df1 is equal to comma df2 is equal to. So here df1 is equivalent to what? df1 is equal to 2 and df2 is equal to 15. So we have to take df1 as 2, df2 is equal to 15 is, now I need to so table where F tab for df1 is equal to 2 and df2 is equal to 15 is 2.49. So our calculated value is this, table value is this. So here our F cal is greater than to F tab. So that is 38.92 2.92 is greater than to 2.49. So the null hypothesis bracket H naught, our cal value is more than to tab value na, so H naught is false, and it may be rejected. This means our null hypothesis is rejected. Hence our conclusion is, our alternate hypothesis will be our conclusion. What we have written in the alternate hypothesis? There are significant differences between between the average strengths of the ropes. There are significant differences between the average strengths of the ropes. So this is our final answer.